All right, hi again. And today we'll be taking another look at the binary gap algorithm. This is the algorithm where you find the largest gap where there is the most zeros. All right, and it has to be bookend by ones. For example, the largest binary gap would be from here to here. That would be your largest binary gap, which is 1, 2, 3, 4, 5, 6, 7, 8 zeros, and there are ones on both ends. So that would be a good binary gap. This will not make a good bind. That would fail the algorithm. That is not what we're looking for. All right, now this is a follow-up to a video I did earlier on a sort of the rough way of doing it, but this way is a shorter, more elegant way of finding the binary gap. Now, what we are going to do is just I have the starter program here, just some variables. I have my string here and some variables that I'm going to be using. It'll become apparent why in a few seconds. All right, so let's get started. So what we're going to do here is just take the wherever there is a 1 in the string, we're going to mark that index. And because it's a string, strings are basically arrays. You can treat them like arrays. And wherever we find a 1, we're going to mark that index. We're going to take the value of the index. So if the 1 is in the index 0, we would take the 0 index number. If the 1 is in the 5th index, we'll take 5 and so on and so forth. And we'll save those index numbers. All right. And that is what this program will do. That's what that program will do. So this is your for each loop. It goes through the string one by one. Wherever there is a 1 in the string, it takes the index and places the index in a vector array A. And here we initialize index to 0. So we count in 0. Then we're going to iterate index and until we get done with the string. All right, now that we have captured all the indexes where there is a 1, let's print it out to make sure that they are correct. And we'll compile using G++ and run. Let's run it. Now, you see the readout of all the indexes in vectors A. That's where we saved all the indexes. And we have a 1 at position. We have these numbers. So these are all the indexes where there's a 1. And you can see in index 0, there's a 1. Here in index 1, there is a 1. In index 5, in index 6, in index 12, 13, and 14, there is a 1. And then again, all the way to index 23, there's also a 1. So just to make sure that that works, we just printed it out using this for each loop here, and that shows that we're on the right track. Okay, now we're going to get into the actual algorithm. Now that we have captured all of the indexes where there's a 1, we can actually get into the algorithm, and we'll be using this regular for loop here to do so. And before I actually start typing, let me just illustrate what the algorithm is about. Now this is the algorithm. This is it here. So we have our array here, and it has all of the indexes where there is a 1. Now, all we have to do now is say from this index, the distance from this index to this index is indicated by the actual value. So we'll do something like 4 minus 1, 4 minus 0 equals 4. That would give us a value of 4, which is, remember, from one to all the way to the next one. The first one all the way to the next one. So we want to capture what's in between that. So we actually have to do a -1 here. If we leave it as just 4 minus 0, we'll be capturing the distance from the first one, to the second one. And that is not what we want. The distance is actually -1. And that's why we have to -1. And that will give us 3 zeros in between. All right, that gap would be equal to 3 zeros. And we go again, we save that value. We save this in something called max. Then we move on again. Then we are going to check the distance from this to this index. And we're using the values inside there. Sorry. We're using the values inside there. So it would be 4 minus, I'm sorry, it'll be 5 minus 4 minus 1. And because there's a 1 next to each other, obviously it's going to equal 0, and that's correct. Because these are right next to each other, these two values. Those two ones are right next to each other, so the gap is 0. Then we're going to move on. Let's go on to the last one, which is 11 minus 7 minus 1. And that would give us 3 zeros. And that would be the same as the first one. So because we're updating the max every time, so it's the same number, so it's not going to get updated because it's not larger than the value that's already in there. All right, so let's go on to the program. Let's program this in. All right, so we'll be going to not -1. We'll be going to size A of A, the array, the vector. So in case you don't know, this gives the size of the vector. So because we will be going from I equals 0 to I less than A size, which would be 1 less than the size of the array. All right, so what we're going to do is we're going to say if A at index I plus 1, right? Because remember, we want to get the largest values first so that we don't get negative values. We can use absolute, but I don't want to do that. So minus A I, that is the index that came before, minus 1 if it's greater than max. Then we're going to add that value in there if it's greater than max. Okay. If it's greater than max, we will add that value in there. We'll say then max equals that. Let's just copy this. Max is going to just equals this. Let's put some brackets around this to make it more clear. All right, and that's basically it. Let's put these semicolons in. And that's basically it. Short and sweet and really elegant. And that is going to give you your max value. Let's see out. Max, and let's see what we get. All right, so let's compile and run this program. That's unexpected. All right, so I'm not sure what happened there. Maybe I didn't save it, but I just saved it. BG, and see we have 8. So 8 is our max gap, and we can check that. Here we are. This is the largest gap. 1, 2, 3, 4, 5, 6, 7, and 8. Yep, that's the largest gap. So that's correct. All right, now, in case you didn't see the first program I did, this is it. This is the other program. This is another way of doing it. As you can see, it's a little bit lengthy, uses a bunch of if-else statements, and I have a video on that earlier. But one thing I just wanted to show you was this. We actually have a bug. We have a bug in our program that we have to get fixed. Control. All right, we have a bug in this, and I'll show you why. Let's put this in here. Ah, come on. All right, so let's run this, save it, and run it. All right, now you see we're getting some gibberish here, right? And long story short, let me show you. Long story short, I did troubleshoot it. Long story short is simply that we have to -1 here. We have to do a -1 here. Because why we have to do a -1 there? Because once it gets to the end here, right? When it goes all the way to the end, this I+1 takes it out of range of the string. So it goes into another memory location that has gibberish in there, right? Could be a memory, some number in there, and that throws off everything. So we have to have this -1 here, and that would help us to manage these range numbers. So let's see if that works, if that helped. Compile and run. Right, so now it works. So now we have 6. Is 6 the largest gap in this number? Let's scan through real quick. This looks like the largest one. 1, 1, 2, 3, 4, 5, 6. Yep, that's it. So that's correct. And that's a nice, short, elegant program on how to find a binary gap compared to this if and else statements. You know, this is just really short and elegant. All right, thank you. Hope you enjoyed that. Bye. There's actually another way to do this using regular expressions, and I'm gonna do a third video on that next time. Have a good one, guys.